Okay, so let's go 11 through 20 now. Yeah, 11 through 20. So it says on number 11, what's the average velocity over the time interval 2 to 3? Okay, well, velocity is equal to distance over time. And it turns out the area of that triangle right there will be the distance that it traveled in that amount of time. So, all right, so we know that it's definitely over 1 second, right? So over 1 second, that's the time that went by, 3 - 2 if you want. But the area of that triangle turns out it's negative. And what that means is um, um, it's moving to the left because our velocity is negative over this time. So over that entire time, because they were moving to the left, we're going to think of that as a negative amount. So it's really, if I'm calculating it, it's going to be 1/2 of 1 times -10, which is -5. All right, let's get back into this. Let's go right here. All right. All right. So to be so 1/2 times, and the length there is 1 times -10. Right. All right. That looks really bad. Let's use parentheses. 1/2 base times height is what we're talking about there. All right. So that's -5. So that means that the average velocity during that time is going to be -5, and we are talking feet per second, right? Yeah, feet per second. To the left. Okay. All right. Next, when does the particle change direction? Well, it was going to the right, and then right here it stopped, turned around, and went to the left the rest of the time. So when it's x, it's x-intercept, right? So at x-intercept, okay, which in this case, it had to cross through. It's more than just being an x-intercept. It had to cross through the x-axis. So being a little bit more specific there is kind of important. So that would be when t = 2. Right? Yeah, because it was going to the right, and then it stopped, turned around, and went to the left. That's what that means. How far does the particle move during the first second, and which way? Okay, so all right. So the first second, we're looking for this area right here, and that area is 1 times 5. So that is 5. 5. All right. So I'll put a text box right there. Okay. And it moved 5 feet. Great. Deleted it. 5 feet to the right. Okay. How far to the right does the particle go, and when does it arrive there? Okay. All right. So what happens then is it's moving to the right until we get right here, and then it starts moving to the left. So the furthest to the right is going to happen at t = 2. Now we end up with a 5 right here because it's just a rectangle. It looks like a square, but it's a rectangle. That's 5. That's half of that. That's 2.5. All right. So 5 plus 2.5. That's this trapezoid, but really it's a rectangle and a triangle. That triangle right there has an area of 2.5. Let me put that in there. Okay, 2.5 right there. Okay. That's good. And that one was 5, of course. Okay, I'm just doing a bunch of text boxes. All right, that's fine. 5. And over here, that entire time right there, it's going to be negative. So I'm going to call it negative. And so it's negative. Let's get rid of that. Negative 1/2. So negative 1/2 times, all right, 1, 2, 3. 3 times 10. 1/2, 3. Negative. It's negative. 1/2, 3 times 10. Okay, which is going to be negative 15. So the area is 15, but it's below the x-axis, meaning that we were moving to the left. So I'm gonna consider it negative 15. All right, so that helps us down here then. How far to the right does the particle go, and when does it go there? Well, it went 7.5 to as the furthest we ever went, 7.5 feet at 2 seconds. Okay, so let's put a text box right here. Okay, so 7.5 feet at t equals 2. All right, next, total distance traveled by the particle. Okay, well, that's just how far to go. I don't care about left, I don't care about right, I just care about how far it went. Well, it went 7.5, and then we went 15, right? Now, I know it's covering old ground because we went to the right 7.5, and then we went backwards 15. But this thing's asking like odometer reading, right? So how far would your car say that you went? All right, so you went that 7.5, and then plus 15. So let's get a text box right here. Okay, so when 7.5 plus 15 for a total of 22.5. Okay, but here's the cool part. What's the position after 5 seconds? Okay, so we went 7.5 to the right. That's a positive 7.5. Then we went backwards 15. Okay, so that's cool. So let's do that. And these two answers are different because one of them is displacement and one is total distance traveled. Okay, and we'll clarify any of this stuff if we need to in class. All right, so this is 7.5, and then we lost 15 because we went backwards. And so that would be my displacement then is negative 7.5. I am negative 7.5 feet, or I'm 7.5 feet to the left of where I started. Okay, so yeah, she says both. Okay, or 7.5 feet to the left. Left to the left. That's how you can say that. Okay. All right. Great. Yeah, I'm doing good. Okay. All right. So that takes care of through 16. Let's keep going. What's the average velocity of the particle over the 5 second time interval? So the average velocity. Now, so that is asking for the average values here, right? So we know it's going to be the distance over time again, right? So again, it's the same thing. So I went negative 7.5. This is my total distance that I have. So I went negative 7.5, and it took me 5 seconds to do that. So this again is going to be distance over time. All right, so average velocity. Yeah, it's going to be a fraction. On top, it's going to be 7.5 minus 15, right? And on the bottom, it took 5 seconds to do that. And I think if you divide all that out, you get a negative 1.5 feet per second. Okay, so it's our displacement, the distance, and then divided by how long it took us to do it. That's how you find average velocity. All right. Question is, the answers to 15 and 16 the same? Nope, because one is total distance and the other is displacement. Okay, so let's write that. Nope. 15 is total distance. Okay, and 16 is displacement. Temperamental. There you go. Okay. 19, the average speed over this 5 second interval. Okay. Well, the average speed is going to be your total distance where there's nothing negative, right? So this is going to be different. So 17 for average velocity, negatives count, but for average speed, negatives don't count. Okay. So this one looks a little different. So this one's going to be 7.5 plus the 15. Just how far did you travel odometer reading divided by 5? And this will be a positive thing because speed is always positive, and I think it ends up being 4.5 feet per second. Okay, not considering any left or right movement, just how fast were you going speed-wise. Number 20, what's the particle's acceleration over the first second? All right, 0. Because it stayed 5 the entire time, right? And there was no change to velocity whatsoever. And also the slope, you could think of it that way. probably the best way to say it. 0. And your answer means the velocity did not change over the first second. Okay. Let's make this look a little bit better too. There we go. Okay, there we go. That's 11 through 20.